Hello everyone, welcome back to the channel. In this video we will learning how to create the geometry of a multi-story building in STAAD.Pro and how to assign different load types which are dead load, live load, floor load and member loads. And in this video will be useful for civil engineering students and structural engineering beginners and those who are learning STAAD.Pro for building analysis and design. So particularly I have taken a problem statement in this video which shows a building with G+3 and base in x direction 3 numbers which are having a 4 meter in distance. In z direction it is 2 number of base with a 3 meter distance. Building story height it is 3 meter floor to floor and total height of the structure will be 12 meters. And material properties are RCC concrete and support conditions are considered fixed end condition. So in this the loads are considered particularly self weight which is nothing but dead load, and then floor load, and then wall load, and then live load. So all these loads will be assigned on the structure, and before that the loads will be calculated. The floor load, live load and wind load and wall load will be calculated, and then later it will be assigned on the structure. So now beginning we have got this particular structure to analyze. For that we need to start working on STAAD.Pro. So however we need to create a folder wherever in the drives with well-known folder name, and here I have taken STAAD. So once I open this, I need to go for new project. I am selecting the space and giving the file name as multi-story building. And then I need to choose the location where I have created the folder. Since I have created my folder on the desktop, so I am choosing that folder and confirming that the length units are in meter and force units are in kilonewton, and then going to add beam and then finish it off. So here whenever we are dealing with a multi-story structure, we have got different options to create here. So first option, we can use this coordinate method. By referring to coordinate method and referring to the building structure, we can go on adding the XYZ coordinates, and then structure will be created. Later we can use this translation repeat method. Using this translation repeat, we can also add number of bays in X and Z directions and also number of floors in Y directions by repeating the same modules. Now in this particular video I am going to use structural wizard. So structural wizard is a direct approach where we can create frame structures easily. So here the frame structure I do consider, double click on this particular bay frame, I will be getting this one. So as we know that the structure length, width and height, the structure height is 12 meter. So number of bays along the height, we can height it is 12 meter, number of bays along the height it is 3, and then in the length direction you can see here in the length direction it is 12 meter in length, and in the width direction it is 9 meter. So I will create that same thing. So 12 meter length, number of bays are 3, right, and the height it is 12, and number of bays in the height is 4, and in width it is 9 meter. So number of bays will be 2. sorry, it is 3. So if you apply, you can see here it is a ground floor. It is a ground floor, first 1, 2 and 3, G plus 3, and in width we have got 3 number of bays, and in length wise we have got again 3 number of bays. So if you can change the properties in length, width and height. So in length wise, if you take it is 4, then you can see the changes of this one. So there are 4 number of bays in length direction, 3 numbers of bays in width direction. So now if you see here, it is 1, 2 and 3 number of bays in length and 2 numbers of bays in width direction. So that means we need to take 3 numbers of bays for width. So as referring to this one, in width direction, if you see, it is 9 meter in width. So if I take 3 number of bays, so it will be having 3 sections. So 3 3s are 9. So likewise, so if you take 12 meter in length, if you take 4 bays, again 3 numbers of 3 numbers of bays will be created. That is what here you can see in this image. So now once we are confirmed with this particular data, so we can add it to the structure. So now you can see here 6 meter in length, so we have 2 bays, each of 3 meter. In height it is 4 number of bays, so each will be 3 meter in height. So in width it is 3 number of bays, so there will be 4 number of bays in each direction, or if you take it is 3 numbers. So for tall it is, if you take it is 4, then you can see there are 4 number of bays in this direction. So now as per our data, we will be having 3 numbers of bays. So after creating this one, I am going to take it to this part, and now it is been created. So as the coordinates are already generated, so now after this what I am going to do, I am going to take this geometry part, and later I am going for general part, wherein in general I am going to assign the structural members. So dimension of the structural members. So once you go for geometry, I will be seeing this property section. In this property section, I am going to define some properties. So defining the structural properties, that is again the basic knowledge of assigning the structures dimensions, that is width and length and depth of the sections. So YD refers to the depth here, and ZD directions refers to width. So YD, so if I am providing the section properties for the width, then for a beam, then width must be 0.23, right, and depth, it is again based on the span. So now the span is again what we have taken, it is a 3 meter, right. So what I will take it is a 0.35 meter. So that means 350 mm by 230 mm in width. That is considered for beam section. For column section, what I do, I will take this as 0.4 meter in cross section and 0.23 in width. So now I have created the beam as well as column. So I will assign these properties to the model. So for that, what I do, I will consider select beams parallel to Y, so that the columns will be selected, right. The select beams parallel to Y. So I will assign these beams properties to the column, and then I will select the beam property, and I will select the beams parallel to X, and I will select the beams parallel to Z, and then again I will assign these properties to the section. So once I assign completing the assigning for property of the column and beam, then I need to go for support conditions. So support conditions, as we have discussed earlier in this video, I am going to consider all supports are fixed end only. So I am creating the fixed end support here and assigning those supports to the structure. To assign those supports, I am considering the front view so that I can easily select all the footings at a time. So I am selecting these footings, and you can see the highlighted dots are footings where this support is going to assign. So assigning these loads. So now on these nodes the fixed end support is being assigned. So soon after this, what I need to do, I need to go for calculation part. So in this calculation part, what I need to do, I need to consider which kind of load is to be assigned first. So as we have discussed that dead load is to be assigned, and then floor load is to be assigned, right, and then wall load, and then live loads, right. So accordingly I am going to create the load cases, and then I will consider the load values in that load cases. So first I am consider the load case details. I am adding here the first, I will consider dead load. I am just entering the title here. For that dead load, again I am creating one more load case, which is live load, and then I will add here. So in this dead load I am going to add wall load, and in the live load I am going to add floor loads, right. So when it comes to the dead load, so dead load, that includes the self weight of the structure. So in this STAAD.Pro model, we will be having the y direction factor as -1, minus defines to the downward direction, as self weight is acting as a downward direction. So I am directly going to add this, right. So for dead load, I have considered the self weight of the structure first, as it is defined that the structure's self weight, which includes the column, beam, and the slab. So now in this dead load, if you see, this is a question mark which is assigned to the load case. So for this, that means it is not assigned to the structure. So what I need to do, I am going to select this assign to view in this assignment method, so that whole structure, whatever is visible in this view, is having self weight. So after applying this self weight, you can see the notation beside this load case will be changed. So now I am going to calculate the weight of the wall, because the wall will come under dead load only. So for that, what I am going to do, I am going to calculate this part. So how we are going to calculate it? As we all know that the wall thickness is 230 mm. Wall thickness is 230 mm. Which and all things lie into the calculation is wall thickness and wall height, or we can say that floor to floor height, it is 3 meter we have taken, and later unit weight of brick, we can say. If you are considering the brick wall, then it will be a brick, and if you are considering any lightweight bricks, then the unit weight of that particular material will be different. So here I am considering brick, which I am going to consider 20 kilonewton per meter cube, or we can say the density of that material. So now, wall load will be wall thickness, height into its density. So that means per meter length. So it will be per meter length. So it is around 13.8 kilonewton per meter length. So now in depth, if you go for any calculation of these particular things, then the beam depth will be deducted, as we have beam depth of 0.45 meter, sorry 0.35 meter we have taken. So if you consider 0.35 meter of beam depth, then if I deduct it, then it will be approximate around 12 kilonewton per meter in that way. So as of now I am considering this for tutorial part, and just to understand how we need to create a model and assign the loads, then I will stick on to 38.8. So how we are going to assign it? As it is in a dead load case, I am going to add one more load value in the dead load case, that is member load. As the wall is acting on the member, I will consider this as a member load, and unit is, you can see, kilonewton per meter. So which is nothing but, which we have taken 13.8 as a total load which is acting downward, right, and then I will directly add it. So now you can see this load is a wall load acting on the floors of the beam. So now if you see, this particular structure is a roof, right? On this roof we do not have the 3 meter wall, so that what I need to do, I need to assign only for these beams, right? So for these beams, if I want to assign, I will select these beams and take the separate view, so that I can easily assign this load to the structure, right? So this is what the box which I have taken, the first floor roof, second floor roof, first floor, second floor and third floor, right? So on this first, second, third floor, I am going to select this beams parallel to X and beam parallel to Z. So all the beams which are selected, even I am considering the inner walls as a main walls itself. So assigning to view, because assigning to selected beams, because here you can see it is been assigned with a downward top direction, means I need to take it to the downward direction, then the directions will be changed. Minus 13.8. So all these loads are acting on the beams. So again I will take this load structure separately, considering display whole structure. So now if I calculate for this particular roof wall load on the roof level, if I consider, again I need to take it for member load. So now for member load, if I take, so 0.23, right, 0.23 is the width, and parapet height I will take, parapet wall height I will take as 1 meter, and then I will take density as 20, then it is 4.6, it comes out to be 4.6. So I will add minus 4.6 as a parapet wall load, right? So I will assign this particular part and considering this front view and taking the new view, so that I can select the wall beams easily. So I will select these beams, as the parapet wall is assigned on the periphery only, though there is no any parapet walls inside the roof. I will select assign to view and assign to selected beams, then you can see this particular thing which is been assigned. So whatever the things calculated, it is connected to only wall loads. So later in the dead load part, I am going to add one more, which is floor loads, floor finish you can say. So generally I will take it 2 kilonewton per square meter as a self weight of roof and floor tiles and cushioning to the floor tiles, so on. So now to apply this pressure, that is floor load on a slab, I need to consider this particular floor load case. So in this floor load case, what I am going to do is I am going to assign this load considering the range of this. So the range, if you see, so this you can see this is a 0 part, means the where XYZ coordinates meets, and this is the height of the structure, which is 12 meter, right? In z direction it is 12 meter, right? So in y direction from 0 to 12 meter, whatever floors will come, that will be assigned with a 2 kilonewton pressure, and in x direction it is 12 I will take, in z direction I will take it as 6, right? So if you see in this way, so that means here it is 6 and here it is 12. So for all the floors I have assigned the self weight of the structure. So if you calculate the self weight of the slab 2, so what happens, 0.15 is the slab thickness multiplied by 25 multiplied by each direction in a 1 meter, so it will be 3.75. So 3.75, again you can add it to the floor load, right? 3.75 plus 2, 4.75. So that will be the total self weight of the slab including floor finish. So later in the live load case, what I am going to do, I am going to consider, in the live load case I am going to consider floor load acting on the live load acting on the floors. Again I will take it as 2 kilonewton meter, that is I will take it the minus 2 kilonewton, and acting at a 10 meter I will take, because on the roof we cannot expect 2 kilonewton per square meter every time, and here it is a 6 and here it will be 12. So what I have done, I have taken just applied a live load on the each floor excluding roof. So if you want to apply a load on live load on roof, you can take that is minus 1, right? So from 10 to 12. So in this range whatever the floors will come, that will be assigned with 1 kilonewton per meter. That is what the meaning of this one. So here you can see only this part is highlighted as a blue, and that means on the roof it is 1 kilonewton, and on the different floors it is 2 kilonewton. So now whatever I have added here, the self weight and wall load and floor finish as a dead load, and on the as a live load I have included 2 kilonewton for each floor. For the roof I have taken for 1 kilonewton, right? So now these are the regular load cases which are added. Along with this I need to have the combination of defining the load combinations. So defining this load combination, so I need to take the multiplying factor. So for 1.5 dead load, 1.5 dead load plus 1.5 live load. You can see load case 3, 1.5 dead load plus 1.5 live load. So again in the load case 4, if I want to take, I can take it to 1.2 dead load plus 1.2 live load, or we can take 1.5 dead load separately on 0.9 dead load separately, right? So what I do out of this, if you consider 1.5 dead load plus 1.5 live load will be the maximum. So now I will restrict here for the load combinations. Once I did with defining the loads here, then I can go for analysis and print. So what I do, I will just click here for all the cases and then go on for analysis. So here the analysis, if once you are done, you should get the 0 warnings and 0 errors. Then you can go for post processing mode, considering these load cases and applying this thing. And here you can see I am looking the results for combination of load 1.5 dead load and 1.5 live load, right? So initially it is been selected with the deflection. If you go on seeing that, you can see the deflection for dead loads, right? And you can see the bending moment and shear force values for this one, right? The diagrams here, and then shear force values for this one. So in this case, if you want to check for any of this one, so any of this particular section, I can take this one. So for this I can take the bending moment and I can check the bending moment value for this. So in result we can go for V value, beam results, and bending at the ends and at the maximum, you can say at the minimum. So 12 kilonewton meter is the maximum bending moment at this section, you can see. So now what I have done, I have taken a separate part of the structure as a column. So now if I want to take the support reactions for particular column, I can take node and then I will go for new view. So in this I can go for again results, V values, and for reactions. Direct global Y direction, it is 426.65 kilonewton of total load which is acting on the footing through column. So whenever we are going for design of this column footing, we need to take this as a axial load of the column. So again, if you want to take any bending directions, then you can take the bending moment at this point. So in Z direction you can take the 4.5 kilonewton meter of, and in the X direction you can see 6.6, and in Y direction however we don't get that bending moment, so it is neglected. So now referring to this biaxial moment and axial load, we can go for designing the foundations. So now after this we need to create a report. So to create a report we can go for report setup. So before going to setup of this report, what I do, I will take some pictures of this one by considering the dimensions, base dimensions here. It is 12 meter in this direction, and in this direction it is 12 meter, height it is 12 meter. So I will take the picture of this one. So after taking that picture, I can go for rendering view for a whole structure. 3D render view if you take. So again you can take this. So after this you can go for preparing the report. Before that we will consider the bending moment values. So what I do, I will consider this bending moment direction means element separately. So this part I will consider separately and taking the new view, right? So in this new view I will take the beam results, right? So this is what the bending moment, that is for 1.5 dead load plus 1.5 live load. Then I will take the picture of this one, and then I will go for previous structure, and then I will consider this column separately as a new view, and I will go for the results again, right? So this is what we can take separately if you want, right? Then I will take this picture separately for bending moment. Again, if I want to take for shear force, I can take this shear force like this, and then go for result, V values, beam results, and then I will switch off this for bending, and then I will take it for shear. And again I will take this picture separately, and then what I do for whole structure I will take once again, so that I can show that this is a column which I have considered, and this is a beam which I have considered for. Just scroll it down so that you can see. So this is what structure what I have taken. So now if I go for report setup, in input I will go for materials which sections which I have considered, materials which I have taken for, and then primary and load combinations. This is more than enough in the input part, and in output in the picture I will consider these whole pictures. And again for output, for results you can go for bending moment summary, right? In detail if you have, want to have any designs, then you can go for this beam summaries. so that it will be having a table of movements, right? So if I want to take reaction summary, I will take, right? Then I will take it to the next, right? Okay. So once I prepare for this, I will go for print, and then I will select the folder where I have created this file to save. Then I will go for here, and then I will save it as a report. So once I have created the particular part, then I will go for this one, and just I will open it and then check it. So here you can see section properties are assigned for column and beam, and then materials which I have selected, and basic loads, and then combination of the loads, factor which I have considered, reaction summary for all the nodes at the end, and y direction you can see the maximum of 1000 kilonewton you can see for combination of light dead load and live load. And similarly you can see the structure rendered view, and then bending moment for column and beam, shear force section, and then the whole structure. So if you do this much, this is a very basic part which is more than enough to understand the modeling and analysis of multi-story structure, right? So this is if you want to have a design of this part, then please do comment, then I can proceed with my further video. Thank you so much for your patience listening.